And we should be live. We should be live. We always double check, always triple check, never assume. That's the one rule of programming. Is you gotta verify, check and verify. So if you are a regular viewer, you might notice there's no background anymore. Well, it turns out I don't have a green screen, but NVIDIA cards have a feature that allows them to do some video processing. So we'll see how that works out throughout the stream. This is a trial run of that feature, but I figured why not try it out. That'll put me on top of the game a little clearer and show more of the game off, because this game is definitely worth showing off. Anyways, we'll hop right into the fun with this Sawayama. Hey, yep, there we go. All right, let's load up our computer here. So one thing I did kind of off stream is I went back to the RedShift here and I was trying to do a little bit fancier programming with it. It's not a lot because it takes a lot of work to get done, but basically we kind of have this Pong-like game, so to speak. The only problem is I wasn't able to get the collisions to trigger for some reason, and I didn't have the modules open. So let's see. Come on. Yeah, so it just goes right through the paddle. But yeah, that's just one ball. Also, we don't have to wait in this EXA that does the ball movement, because it takes so long to process that it's actually slower than a frame. It's pretty bad. There's probably a better way to do it, but hey, you know what? There's no like clamp or anything, which would be great. Not clamp, but kind of like a flip something. Anyways, all right, here we go. Moving into Deadlock's domain. What do we got on the schedule? Oh yeah, we're fighting Deadlock. Compete with an opponent to grab files and bring them back to your host. It's another competition here. I think we've done 3 competitions already, haven't we? Like Valhalla. I thought there were more. On to the third. Yeah, the third. Yeah, that's right. Is each match against a better programmer than the last? Better is subjective. That's true. It's hard to judge like better or worse. Everybody's got different strengths. Makes for an easy narrative. Sure. All right, so we got 3 files. To win this battle, you must grab files as they spawn in the central hosts and bring them back to your host. Reading the file register will tell you the ID of the most recently created file currently in that host. Gain 1 point for every file you bring back. Lose 1 point every time one of your exes executes a kill instruction. Okay, so let's not execute a kill instruction. For more information, see Hacker Battle Domination. Okay, so I think what we're gonna do, we have a size of 3. So we really only need to spawn 2 more copies. We're not gonna be destroying the other person, so we'll want them to target different nodes. So we'll probably do like copy 802 into X, and then we'll REPL run. We'll copy 801 into X, and we'll REPL run, and we'll copy 800 into X, and then we'll mark run here. So this will kind of be our main game loop. So unfortunately, kind of the problem here is that we can die if we attempt to grab the file and it's not available. That will terminate our EXA. We can only have 3 EXAs, which kind of stinks, because in theory we'd want 4, where we have like a spawner at all times. So one possible option I guess, would be if we do keep the 1, we have plenty of room. I can't see what I'm pointing at. I don't know why I'm trying to do that. We have plenty of room on this main stage, so each one of these squares can hold an EXA. So what we can do is we can just go ahead and link our main EXA out there. That'll be one less step that our sub EXAs will have to do. And I wasn't originally going to do this, but we'll make it an infinite loop. I don't know why I called that jump. That's a bad name for it, and I totally butchered the word jump command. Okay. So the idea here is we'll just spawn. So we'll do what we were doing earlier. We copy 800 into X, we REPL run, copy 801 into X, REPL run, copy 802 into X, REPL run. And then we'll redo that over and over again. Now we're going to quickly fill up our storage limit because we can only have basically 2 extra X's, but every time they fail to grab a file, they'll die. So what we're going to do is we're going to make them quick and easy, right? So the first thing they're going to do is they're going to link X. So they'll jump to the node that they were targeted. They will copy file. Actually, I don't even need to do that. They just need to grab file because we can read directly from that register. And then we can link -1, link -1. We're back here, and they'll halt automatically. That'll free up for a new EXA. So in theory, we hop here, we create an EXA, it jumps here, it grabs a file, takes it back. We're grabbing files. We are slowly in the lead, but only barely in the lead. It's looking pretty bad. Looks like they have a similar pattern to us, honestly. Can we keep the lead? Barely. We can barely keep the lead. How long will we hold the lead? Okay, we got 100 wins. I'll take it. I'll take it. That was quick and easy. If you have some friends, you can actually challenge them, like actually head to head with other players, like PvP that, which would probably be a lot more fun. Let's see. Curious how enthusiastic everyone gets about the battles. Something about competition energizes people. Makes me wonder. Yes, I understand the drive to compete. That's something I'll have to investigate more. Yeah, the drive to watch. Oh man, well that's me. Who's gonna take on Mox next? X10? Sure, later. My exit dev rig is broken. Sure, it's broken. So I think we've done Deadlock and Plastered, right? Valhalla was Plastered, and the right there, KGOG-TV was Mutex. Hello, Alexi. Whoop, that's caps lock. Howdy, I can't type words. I failed to type words. Yeah, Mutex was first. So we haven't done X10 yet. Let's see, Xtreme League Baseball. Retrieve extreme baseball statistics and use them to determine the best player. Well, that sounds positively challenging. You should be glad I've been reading up on sports. Remember when I said I'd figure out the money situation? I've designed a new rating system for extreme baseball players. It's based on a multi-vector analysis of all the stats. To predict winning teams, a few bets here and there, and I'll be rich. Cool. So we have a lot of files with a lot of data. Usually the expanded files mean that we're going to be reading them. The host's active and penalty contain files that correspond to extreme baseball players, along with the directory file that contains a list of those file IDs. So file 199, where are you at? 199, 119. That's all the file IDs. Each player file contains their name and the following statistics in this order: BAZA, APB, WRT, OIOD, PC, and PS. I'm not a baseball stat person, so I'm pretty sure if you are a baseball stat person, those will make sense to you. They make no sense to me. Create a file in your host with the name of that player, with the name of the player with the highest score. where score is BA plus ZA plus APB divided by 3, and basically this formula. Players in the penalty host should be ignored as they are currently banned from the game. Okay, so I think ideally we kind of have, what I'm thinking is we split the work. We can have a few X's on that machine at a time. So if we have one Exa holding the file, it can spawn X's to read from the file. Are any of these files, so 219 is here, 261, 265, I'm looking to see if any of these files are on the penalty box, 288, 206, 252, 205, 220, I don't think so. I'm using NVIDIA on card technologies to digitally remove it. Yeah, it's cool. It's the cheapest green screen you can buy because it's not a green screen. Well, it's cheap if you already have an NVIDIA card. If you don't have an NVIDIA card, it's probably more expensive than a green screen. But yeah, don't have to chroma key anything. Just kind of puts more focus on the game itself, and less focus on what's around me. What do we got here? So we've got to do this complicated formula, and we've got to read the files, and we got to find. So what I was saying is, if we split the work among several different X's and have each of those working, then they can come back and independently report. The problem's going to be in communication. I love how they have the bases over here. Like there's no way to link to, oh yeah, $7.99. So we could just have somebody running around the bases for fun if we wanted to. Anyways, what was I saying? Yeah, so if we have a bunch of different X's reading the files, processing them, calculating these stats here, which luckily they're in the order we need to calculate. That's totally probably not intentional. I bet that wasn't intentional at all. That's sarcasm, sorry. Let's see. Yeah, so communication from X to X is a bit limited. We could listen locally for communication, like on this node, but if we have more than one Exa pop back and start communicating, then there's no real way for us to stop that, basically. Like they're all three going to send us a signal and the game will decide which one we read from. So that kind of makes it troublesome to have a whole bunch of X's working on this at the same time. Yeah. So the simplest solution to that problem would just be one Exa processing a file, coming back, reading its data, and then kicking off the second one. That's definitely going to up the cycle count, but I want to see how bad the cycle count's going to be, because that's going to be the simplest approach. So we're going to have one reader. Let's make two X's. So this will be our reader. We're going to link 800. We're going to grab 199, and then we need to mark the loop here. Jump the loop. So test EOF. Because we're at the end of the file. You know, we can do that at the end. That's fine. Test EOF. If it's false, we'll start the loop over again. Okay, so the first thing we're going to do is we're going to copy F into X, and then we'll REPL read and or REPL calc, and then we'll void M, so we'll wait for like a global signal to move on, and then we'll trigger this one to local communication. We're going to make a file for it. And then, oh, we need to finish this one. So mark calc. So the calculation portion We'll grab X. That'll grab that file up. That contains all of the information that we need, so we just need to calculate these values, which should be fine. So we need to add the first three together. So we're going to seek one because we don't need to add their name to anything. BAZA APB is all added. So add I, F to X. Oop. Let's copy. About to copy 0 into X right before I grab X. That's not going to work. Copy 0 into X. We want to start with 0. Actually, no, we can save that command if we just simply copy F to X. We'll just copy it out. We don't have to worry about setting it to 0. Then we can add I, F, X into X. Add I, F, X into X. Then we want to divide X by 3 and store that into X. The next two values have to be multiplied together. So we want to copy F to T. We want to mul I, T, and F and store that into T. And then we need to divide that. So div I, T, F into T. And then those parts are added together. So at that point, we can add I, X, T, and store that into X. Then we've got PC minus PS. So if we copy F into T, sub I, FT into T, and then we want to mul I that by 20. Just a hard 20 multiplication there, and then add I, X, and T, store that into X. Then we can copy, we'll seek back to the beginning of the file, and we'll copy the name into T. We'll drop the file, we'll link 800. Oh no, we don't want to link 800. We want to link -1 to go back to our home connection, and then we'll simply copy X to M, copy T to M, and then that'll be the end of that node. So this node makes a new file. Jump loop. Let's see, mark loop. We'll handle. I just realized we need to handle like when do we stop waiting. So we'll take care of that. What this is going to do is we're going to copy F to X. Well, first we're always going to do the first one, so we're going to copy X to F. Should we do the name first? We need to send the name first, because I think that's what the output wants to be. New, it's just the name. We just care about the name. So let's copy the score and the name. So copy I don't even need the score. We're just gonna put copy 0 to F, seek -1. And then we'll do a comparison here because we don't need the score. We do need the score. Copy M to X. Okay, we're going to copy that into X. Then we're going to compare it. We're going to do test X less than 1. Why did I do that? Test X is greater than F. If it's greater than the current score, then we're going to take the name. Let's see, copy 0 into F. Yeah, and then seek -1. Okay. Copy M to X. This is not fun. I'm trying to think of how we're gonna terminate, basically. If we were to write scores into a file, I kind of like that. We could spawn more X's. Yeah, I think I kind of like that idea, because then that'll be easier. Okay, so new approach. We're gonna process it in multiple X's at once, without this kind of waiting here. And this is going to do the calculation that we have. It's going to drop the file. And then we can't hard code a file ID, can we? I think there's a command. If we look at the books, I'm not gonna share. It's a quick lookup. If we look at the instruction set, there's one for host. I think there's one that gets us the ID of the current file. Seek file, grab, make, create and grab a new file. There's not one that gives me the ID of the current file. Well, that's not cool. We got copies. Shoot. Well, that was not a bad idea, but it wasn't a good idea. Or, well, I mean, it's not a bad idea, but I think we're gonna use the inherent kind of delay in creating them as a way to ensure that they're not overriding each other. So we'll have this node kind of be our source of truth here. So we'll make a new file. We'll link 800. No, that'll reduce, because we'll have one node there. One will grab the file. I think it'll be fine. We should have plenty of room. We link 800, and then we will copy mark right loop. We'll just jump right loop, break out of it eventually. We'll copy M to F, copy M to F. That should be the name and the score. And then we can test MRD. That's not going to work. We can copy M to F to T. And then here we can sub-I T1, store that into T, and we will T-jump back to right loop. Okay, and then the first thing that this one's going to do, we grab 199 and we mark count. We're going to count basically how many files we're going to read. So for each one, we will add I1 to X and store, well, I like to do the register first. Doesn't really matter, it's addition. So we add 1 to X, we test, we need to seek 1, test EOF, and then F jump. If we're not at the end of the file, we'll go back to count. If we're done counting, we're gonna copy X to M, and we'll be local. And then once that's done, we'll swap modes back to global. Then we'll go back to the beginning of the file. We'll do this per normal, and then down here, we'll simply not link one. We'll just copy X to M and T to M. And that should put us here. So once we're done writing, we'll link back -1. Now we've got to basically figure out who's got the higher score. So if we seek to the beginning of the file, what we can be sure of is that the first score will be the highest score. So we just seek 1 after that. So we seek all the way to the beginning, which should be the player's name. That's the score first, yeah. So that'll be the player's score, so we don't need this extra seek. The first one in the file will be the player's score. Hey, how are you doing? Thanks for joining. Thanks for tuning in. We're just trying to rig baseball betting. You know, fun stuff. It's a good thing it's a game and not real life, or I wouldn't be streaming this. Don't stream crimes. As I was saying, yeah, so we're gonna read the player's name, or the score first. So the first one's the highest score, actually, so we can seek. We'll copy F into X, that's our highest score. And then we'll seek 2. That's when we'll mark compare, and we'll jump compare for now. So if we are, actually let's do our test UF, then we'll, if we're not at the end of the file, we'll go back. Okay. So in compare, what we're going to do, we have the current highest value in X. Oh, I don't need 2, I only need 1. Okay, so we're going to basically test if F is greater than X, then we're going to cut it out. We're gonna remove the first value. So that's going to be jump. T jump. I'm going to call it replace. If it's not greater than, we want to remove the current values. So we'll seek 1, and we will void F. We'll remove the score and the player. And then over here, we've got mark replace. And what we'll do in mark replace is we're going to seek back to the beginning. So the first 2 should always be our main 2. We're going to void them out. And then we'll copy F to X. That's our new highest. We'll seek 1, and we'll jump back into compare. And then here, what we'll do is we'll jump to halt. So that should end us. And oh yeah, actually, when we're done, instead of jumping over there to halt, once we have done reading everything, we're left with the score and the player name. So we need to seek -999, and we're going to void F. We're going to remove the player's name, or score, and keep their name. If everything worked well, then that should be good. We'll see. We'll see how that works out. So we're counting up how many we have, and then we're going to copy that over into there. So we're reading 10. So we've got 10 little X's, more than 10 little X's. Ooh, we are spawning them like rabbits. Look at that. Okay, we've got, you are stuck waiting. Why are you stuck waiting? What is this one doing? Oh, they're all global. They're all global. So the first thing that Calc needs to do is swap modes. I don't know, like, why is that necessary? The main one's not going to be reading anymore, so it can just stay global or local. That's fine. I forgot to finish. When this is done, it needs to halt. Yes. So we count up how many files we've got. We've got 10 files. Let's just skip right ahead here. We want our first little exa. Boom, we got it. All right, our first calculation X is going. We're doing some math. We've got some numbers together. We're copying them over, so that should be hitting our... Okay, and you're done by the time this one's here. I hope these scores are correct. Okay, so that's the problem. We got two numbers together. See, we've got too many X's running at the same time, and they're running too in sync. I wasn't afraid of that, but that is a big problem that we have. Where are we spawning them? We're spawning them here. If we arbitrarily put in, it's not wait. It's no op. If we arbitrarily put in some no ops, we can tell this exa to like pause, give some space for communication. And that will spawn a bunch of X's to calculate. And we want to watch these numbers come in. We should hopefully avoid any double ups, any double names or double scores. Okay, so we're done now. Everybody's halted. We're back here. We've got 593. We test it. We jump to... Oh, we don't replace. So we void out those two. We're not at the end of the file. We compare. It's not higher. Okay, we do have one that's coming up that's higher. And it's going to be David Dwight. Okay, so we go back to replace and we copy those out. That's working flawlessly, I've got to say. Boom, boom. Why are we... Well, we didn't halt. Okay. Where are we at? We were here. Yeah, we void that out, and then we need to halt. Okay. Feel pretty confident in that. Okay. Wait. What's happening? Why is it called new? I think it doesn't care. Oh, we have the wrong name. Do we have the wrong score for Kingston? Which file is Kingston in? Kingston is in... Wait, where? That was the number 2. Kingston's in file 273. Let's watch this one. And we want to get to the point where... Yep, you are banned. Please don't advertise against the TOS. Thanks for chatting, but you advertised against the TOS. Let's see. We're trying to debug here. We want to know the one that's going to grab file 273. 273. Okay, we're here at 273. We're going to copy 273 in. We're going to REPL. Okay. Now let's find that exa right there. We're going to pop that one out so we can keep an eye on it. It's going to seek one, copy numbers around. How did we get a negative? We got a negative in there. Should we have gotten a negative? Jim Kingston, if I do the math, I'm going to have to pull up a calculator. Oh my goodness, calculator. What do we got? Let's do this math by hand. According to this one, we got 315. So we need to do, let's focus on this file. Can I pop you out? There we go. Okay, perfect. Okay, 329 plus 427 plus 222 divided by 3. So we're at 326. We got 326. I also need my notepad up so I can keep track of these numbers. 326. Then we're gonna clear that out. The next step is multiplication. So 129 times 3. 129 times 3. 387. Gonna clear that one out, and then we've got, oh, that's what, no, that was 387. We're not done there. 387 divided by, where did you go? Oh, you're right here. Boom, 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 divided by 3. Oh, times 3 divided by 3, for real? That's like a no-op, right? 129. Too bad implementing that as a no-op, like as a short circuit, would be just a nightmare in performance. Then we've got 9 minus 2, and that is times 20. Okay, so that's 140 plus, I don't know where we got negative from. We got to check on that calculation. Except PC minus PS, yeah, I don't know. 140 plus 129 plus 326. We should have 595. So we're definitely gonna have to rewind. Stop this. I want to, just so I know, I want to test x equals 273. And we're just gonna like mark temp. If it's not 273, we're gonna jump straight to temp. Otherwise, we're gonna no-op. That way, I can just hit no-op, hold Alt and no-op, and it should halt there. Yeah. So we've popped that one out. That gives us a way to target the one we're looking at, and then this is the file we want. Okay, so it grabs that file. It just took it off the screen. Okay, so we seek past that. We do 329 plus 427 plus 222. That's 978. Then we divide that by 3, which is hard-coded. Okay. Then we do 129 times 3, which is 273, divided by 3, which is 129. Okay, that matches. Then we add that to X. We've copied the 9 in. We subtract. Ooh, I got that backwards. Oh, man. Because we subtract the number that we just read, which is going to be... I wonder, could we literally just do, could we read from F twice? Is that going to work? So that would mean that we don't need this command here. Is that crazy enough to work? We don't know. Let's see. Okay, we got our little thing back out. We don't need that out there because it's going to pull it over here. Okay, so we know everything there is correct. Oh, apparently the apparently that did work. We skipped right over it. And then we add that together. 595 was the total that I got? Yeah, 595 is what we wanted. Okay, so we should be correct now. We're stuck again on test 7. Test 7. Why are we sticking here? Okay, we've stopped because we have picked... Who did we pick? We picked, where's 400? We didn't clean out the score. We picked the right person, but we didn't clean out the score. Are there any others that I could do that to? We've got... No, because that has to take into account F. Like, we need the value of X. We can't just do F plus F. We could do add I, F, F, and store that into X, and then we could get rid of one of these add commands. So that's 1, 2, 3 reads. That's 1, 2, 3 that we're adding. I don't want to get too creative right off the top here, but yeah, that's interesting to know that we can just back-to-back read from F. I don't know why I never thought of that before. Okay, we need to figure out what happened. That was going to be in our halting here. So we need to get to this point where we're testing. We've got 437, 431 is not less than, so we go back, we delete those two. Then we go back to compare, we do the comparison. That's not true. That's not true. 297 is not true. Okay, here we are. We are 807. So we go here, we delete, we seek one, jump compare. Oh, we don't do a test. Okay, so we need to move our test EOF up here. Test EOF. If it is not true, then we go to halt. I guess, well, let's not call it halt. Let's call it what it is. We're done. We figured out what we need to do. Okay, then we do this test, and then once we get here, covering up the code, once we get to this point, we want to just jump back to compare. We're ready to do it all again. Okay. Kind of stinks because we know that we're not going to be at the end of the file at the beginning, but that way we know. Yeah, we clear that out. Perfect. Okay, that was it. That was our final bug. Yeah, okay, so network activity. There we go. Cycles is looking great, but we did multi-thread it, basically. We created a bunch of X's to do the work in tandem. Parallel. We've got a pretty large size, though, which I'm fine. We could probably reduce the size if we didn't have all of the logic for searching and finding. We could try to intelligently keep. So one improvement that we could make, I'm going to go ahead and return, and we'll go back in and edit. Processing. I should have said something. Better you learn on your own, because I'm trying to help you. Okay. So if we jump back in there real quick, oops, does it not let me create a new? Oh, here we go. Yeah. So we want to copy this solution, and then we're going to go back in here. Okay. So one optimization that we could do is what we're doing here. We're writing. We're basically copying what we have. So we could say that our initial copy is going to be, and then we'll copy X to F, and we'll copy copy M to X, copy X to F, and then we're going to copy M to F. So that keeps our same score name kind of pattern. But now we're going to compare as we receive the values, which is probably actually going to be worse, but we're going to try it. We're going to try it once. Oh, I say it's going to be worse because then we're going to have a backup of X's wanting to write to us. And so they're going to write multiple things to us, which is not going to work out. But I mean, what can you do? You know, what can you do? Okay, let's see. We're going to copy that directly into the file because we know that that is our best looking one so far. And we'll go ahead and seek 999. Okay, then right loop. Oh, this is going to replace the test value. See, this is where problems abound because now we've got to move. We got to move this into F. So that's our now control variable. We seek back to the beginning, then we seek forward 1 to the score. I don't know why we're doing that. Then we'll copy M to X. We'll copy M to X, and we will test it now. We're going to test that. No, we don't want to test. Oh, yeah, copy M to X. That's why we're seeking. We seek back because we need that one, that number that is our maximum. We're going to test X is greater than F. If X is greater than F, then we're going to T-jump keep new. If we're going to keep the old one, we're going to void M. We're going to get rid of the rest of that data. And we're going to seek -1. And we're going to jump right. We'll jump test right. And then down here, we'll have our test right. Mark test right. And this is going to do our test. So we've got to seek all the way back to the beginning. So we might as well not seek -1 there. We're going to sub I F1 into X. We're going to seek -1. We're going to copy. Actually, let's sub that into T. Then we can simply, if that's false, we can chop done right. And we'll mark this as done right. Okay, so if we're not done writing, we will copy, we'll seek -1, we'll copy T into F, and we'll jump right loop. Okay, we want to keep new. Mark keep new. So if we're keeping the new values, we need to seek -9. We just need to seek back 1. That's where the score is. We're going to copy X to F, copy M to F, and then we'll jump right loop. Just like that. Right. And seek -1 back so that we have the score set. Okay, that's a little beefy. But then we're basically what we do here, we link back, we sync all the way back to the beginning, we void F, and we halt because we're done. That's it. That's all the code there. That's actually too bigger, and I'm pretty sure it's not going to function as we would hope. We're currently counting up. We've got our 10 in there. We've got our little bots adding up. They're writing values in. We're comparing everything against 353. 776 is bigger. We wrote some values in the wrong way. So let's do keep new. No, we want to right here. So we seek -1. We copy X to F. We copy M to F. We need to seek 2. Okay. Yeah, so let's get back here. So we keep that one. 421. 455, 476. Why are we not done? We are done, but we're not done. Are we not subtracting from here correctly? So we sub 1. We seek -1. We copy that in. And we do it again. Oh, test right. Test right needs to jump, done. Oop. Wait, no, that was correct. What is it? Keep new needs to jump to test right. Because we did just read one. So every time we were keeping a new value, we were essentially not decrementing our tester. Okay, so 7.6. 4.55. So we're already, something's already off because we should be keeping David Dwight, but we're keeping Billy Book. Yeah. So, oh, I just realized we still have this code in here, which is actually great. Great that that's in there, because where is Billy Book? Billy Book is 288. So we could just change that to 288. And we can run. So we're here on this node, and this node calculates. You're not Billy Book. Where's Billy Book's node? We're gonna pop this one out so we can keep track of it. It calculates 248 for Billy Book, but we're consistently reading 7. Yeah, so just as I thought, we've got some concurrency issues in there. We can cut the size down on this one authentically by just like removing this temporary marking test code that we've got. So that gets us down to 67. That's not a huge save, but it's noticeably brings us back. I'm pretty happy with that. Okay, reset ownership information of virtual real estate in King's Ransom Online. Oh wait, we've got here, man, war dialing's a slog. I found some weird stuff. I found a power company and something to do with insurance claims. Eventually you'll come across the DNA database run by FEMA. Did you know people pay real money for items in online games? Yeah, it's pretty common. It's a booming business. Normally it takes a lot of skill, but if someone were able to change the ownership of those digital objects, that person could become wealthy overnight. Not suggesting that I do it, but suggesting that I try. Okay. Okay, what do we got? We've got to terminate all other X's. Okay. That works. Reset the ownership of all castles and sub-buildings to P00000, so that's file 300, the player ID for unknown buildings. To ensure that there are no witnesses, you must first disconnect all connected players. Terminate every EXA and every host before changing any castle. If you leave an EXA alive in one host while changing a file in another, you will fail the task. Networking. Okay, so annoyingly, what is 200? So that's who owns that, and these are all sub buildings. So 259 is also on that node. Okay. But we've got some X's holding files too. It looks like we've got up to 3 X's per node. Is that an assumption that we can make? None of these test cases seem to disprove it. Let's go ahead and look at our booklet here to see what we got going on. Where are you at, booklet number 2? And we will turn that on. So folks at home can follow along, because I know that's the favorite part of the stream, is reading the book. What do we got? King's Ransom right there, page 13 in the book. Here we are, buildings. Each building in King's Ransom Online possesseth the following format: name, type, owner's player ID, and 0 or more numbers that are file IDs of sub-buildings of this building. Verily, sub-buildings can even have their own sub-buildings, such as Legendary Wizard's Tower. Furthermore, each weapon possesseth the following format: name, damage type, damage type, speed, weight, durability, 999, perfect, 0 equals broken, and any special effects. Beware, warrior, such knowledge is dangerous. That's really it. That's it. Do we have any weapons? We have buildings, we have guilds, we have castles, metalsmiths' quarters. I don't see any weapons in test 1. Test 2 also doesn't seem to feature any weapons. And the same with test 3. Okay. So we're going to go under 2 assumptions. 1, that there's no weapons, and 2, that there are up to 3 X's. So we're going to copy, or we're going to grab 300, copy F to X. We're going to wipe that file because we don't need it anymore. Then we're going to, we need 1, 2, 3, 4, 5, 6. 6 nodes that we're targeting. So we're going to, we'll just do it 6 times, right? We're going to REPL seek and destroy. I should probably copy 805 into T. All right, then we'll REPL seek and destroy. We'll copy 804 into T. REPL seek and destroy. We're going to copy 803 into T. REPL seek and destroy. Copy 804 into T. REPL seek and destroy. You know what? Let us do optimize this a little bit for writing. We're gonna copy 5 into T, and then we will. I lost my train of thought. Mark's seek and destroy loop. We're going to add 800 to T and store that into T, and we're going to add I. I don't really know what the I stands for. It probably stands for something. I just realized I still have the browser up. Hello, browser. Goodbye, browser. Browser's gone. Sorry for the interruption there. Okay, we're marking to seek and destroy. We're adding 800 to T, and then we will REPL seek and destroy. We'll sub I 801 from T into T. So that's the same as subtracting basically 1. So the first one will be 5. We add 800. It's 805, and then will be 800. Now the thing is after we seek and destroy, we want to. We're gonna have to do this sub I 800 T into T. Then we're gonna have to T jump. T jump. If it's still true, we're gonna send loop, because if it's 0, we need to bail out at that point. But we need to spawn 800, so we need to bail out at that point. And then we need to sub 1 from T. But this time it's T1, and this is subtraction. I just realized, so we have to do the larger number first. Or we're just gonna cause problems for ourselves. Okay, and then once that's done, we'll halt. Here we'll mark I just realized Okay. What do I need to do? Let's start. Okay. Let's copy 6. We're going to copy 6 in. And then here, we're going to F jump. Halt. Sure. I don't want to call it halt, but I don't know what else to call it at this point. Then we add 800 to it. We don't even need to add 800 to it. We just need to REPL, seek and destroy. Then we can subtract 1. Okay, so that actually simplifies it. If we go back, I know I'm hopping around here. If we go back, no, we still need it. We still need it to be, yeah, we still need it to be, okay. So if we're false, if we're 0 now, we're done. So halt, spawn S&D, subtract 1. And then while that's true, go back to the loop. Okay. Yes. While that's true, go back to the loop. Yeah. Well, that should work. No, because then 0 would be okay. I keep second guessing myself. Stop second guessing yourself. Always trust your gut. Mark halt is just going to do nothing for now. And then we'll jump halt here. Mark S and D. Okay. So once we're out of the loop, we will halt. Inside here, we're going to simply sub I, T1T, add I, T800, and store that in a T. Then we're going to link 800, link T. Okay, T's done. We're done with T. For now. Now we need to spawn our killers. So we're going to REPL kill, REPL kill, REPL kill. And the reason we do kill this way is because if there's nothing to kill, it's going to halt anyways. So we want to make sure that that's another exa that's done. So those are gonna kill. So we'll no op after each one, just to kind of be sure, and then we can grab 200. Now the fun starts. So it doesn't really matter what we pick up, if it's a castle, a building. Because we don't have a way to generate strings anyway, so we can't randomly compare to that stuff. So what we're going to do is we're going to seek to, and we're going to copy X into F. So we'll start at Averford Castle here, and we'll seek 1, 2, and we'll put the new player ID here. Then, if we can spell seek correctly. Then we'll mark sub loop. And so if we're at the end of the file, we F jump halt. No, if we're at the end of the file, we T jump halt. Otherwise we jump sub loop, where we copy F into T because we still need X. And we REPL replace. Right, let's mark you replace. We're gonna copy 200 in T, so this can just become grab T. And then sub loop, we REPL replace. We jump sub loop. That should be it. Once we are, yeah, okay. Let's try it out. Boom. We have red. We spawn. That one goes. It goes here. It spawns a killer. It killed itself. Huh. Maybe is kill safe? I wonder. What if we just run kill? Like that works. That worked there. That worked there. Yeah, I think we can run. Yeah, we can safely run kill ourselves. Not a concern. Okay. So that one eliminates everybody. We're following 0. Let's pop 0 out. We're following along the life of this Exa. We copy that. We copied the player name here. We're not at the end of the file. So we copy that entity. We REPL replace. And we go back. Now we should have XA00. Where's XA00? Somewhere down here. Okay, we're gonna pop that one out. And it grabs this enchanter's building. It wrote that, and then we have another sub building, which somebody should be looking at. XA000 here is looking at 244. Perfecto. It did do that. Okay, perfect. Yeah, these things seem to be working. And everybody is cleaning themselves up. We have left no trace, but what do you mean we didn't terminate all other X's? What? Interesting. So we've got to kill all X's first. We've got to kill all X's first. So we really need like what are we doing here? Before we do this, we want to do a like kill loop. Kill. It's not really seek and destroy anymore, is it? It's more like seek or claim. Yeah, let's call it claim. And we've got kill loop. Okay, so S&D is now claim. We do still have kill here. Kill will link 800, link T, kill, copy 1M. And then here we will mark kill done loop. We will copy. Is that gonna work? We'll void M sub I T -1, and we'll T jump if that's still true. Kill done loop. Because basically we're gonna send off 6 killers and then we're gonna wait for them to finish. They are going nowhere. Why are they going nowhere? Because I'm not. Because add I 800 to T into T sub I T -1 into T. Gotta do that again. So they're all dying. Whoa, why did we stop? Oh, you don't jump halt. Shoot. Yeah, we don't need to jump halt at the end of that. Spawn them, we start waiting for them. We get their signals back, then we can start spawning our workers. There we go, okay. There we go. Okay, all right. We're not actually bad on cycle. At 99 cycles, that's actually not bad at all. Size, pretty average. We are high on activity. I don't really know a better way to do that, honestly. We've got to orchestrate. We've got to destroy literally every exa, and then before we start, we can't start on any node with a single exa up. Something about hackers. People are taking it so seriously. I did not mean to select that option. Do they got... Oh, shoot. What? My guild's castle was stolen. I was suddenly booted. Now it's not ours? Ooh, we took their castle. Sounds like it was hacked. That would be a pretty bad hack. Alright, folks. I need to take a quick break. Give me one moment. I'm back. Thank you for waiting patiently. Boom. Okay, back to KGOG-TV. KGOG. Upload a new television program to a satellite broadcast system. Sweet. Art moves people in certain situations. An expression of some of the ideas I've been developing. Let's get it out there. Align the satellite dish with the target satellite by setting the azimuth, elevation, and frequency, then transmit the data from the 301 file. After encrypting it using the TV station's encryption key, file 199. The azimuth, elevation, and frequency of the target satellite are available in 300. Note that you must align the satellite dish before transmitting any data. For more information, see Look to the Stars with Satellite Uplink. Okay, more book, but this time I'm going to remember to turn off the browser. That is here. We've got something about uplinks 22. Page 22. Here we go. Establishing a connection. Though they might seem intimidating at first, satellites are really just expensive computers that happen to be in orbit around the Earth. The dish. Okay, that's not really helpful. That's what a satellite is. Do you know what a satellite is? That's what a satellite is. The next concern is encryption. Wait. Where does it say? Okay, we've got elevation, azimuth, and frequency here. I don't think... Okay, the encryption's really going to be the part that we need to read about. Since anyone can point a satellite dish at a satellite and blast away, almost all systems reject any transmission that aren't encrypted with a private encryption key. If you do get your hands on a key, though, it's pretty simple to implement. To encrypt a sequence of values, add the first value of the key to the first value of your data, wrapping back to 0 when the sum reaches 10,000. So if the data value was 7407 and the key was 3894, the sum would be 11301, which would be transmitted instead as 11301. To encrypt the second data value, use the second key and so on. If your message is longer than your key, you'll run out of key values. In this case, go back to the beginning. Yeah, okay. Pretty straightforward. Okay, so... Wow, how are we going to handle that 10,000 limit? That's going to be the real challenge right there. I almost went back without turning off the browser. I almost did, but I turned off the browser. Okay, so if we were to add like 6329 from our output to like 7792 from the input and store that into X, we get 9999, which is not good. So we for some way we have to know if we're going to carry. It's almost like we have to add all of the digits themselves and then kind of add the final bit itself. There's a way we could do that. What we would do is, in this case, we would copy 6329 into F. We'd make a file first. 7792 into F. Then we can take our we'll swizz, we'll seek back to the beginning. So if we swizz F by 0321 into X, as you can see, what that'll do is that'll put 329. And then we can swizz F 0321 into T. And so we pulled that out. So now we can add I, X, T into X. So we've gotten that point. Whoops. We've gotten to that point where we have 1121. Then we simply add the last two values, which is not as easy as I thought. Is it? What am I missing? What am I missing? We need to know what it overflows by. So we need those two values. But we also need the new values. So it's like we need operating space. So let's just assume we have operating space. So now we can, we've swizzed those two. We can copy X into F, right? So that puts it at the end there. Then we can seek back swizz X to T. No, F, and we just want 4. F to 4 into X. Swizz F to 4 into T. That's just those two values, 6 and 7. I did not mean to hit escape that many times. We can simply add I, X, T into X. That gives us that. That is 13. So now we can sub I X 10 into X. Mul I X times 1,000 into X, and then add I X F into X. And so that should be our wrapped value. 4,121. Is that the wrapped value? Where's my handy dandy calculator? Handy dandy calculator, we have 6329 plus 7792, and that is a 14,121. Boom. So that's basically our operation for encrypting the values. That is a lot of effort to encrypt a value. It is going to be kind of annoying to encrypt values that way. I don't think, do we need the title of the video? We probably do. Well, let's see what the transmit log shows. The transmit log shows just the numbers, so I'm going to say no. So we'll probably have one node, one EXA reading file 301. We'll have one EXA reading file 199. They will both write to an EXA that's reading both of those numbers in, and then that EXA will process them in this way to encrypt them, and then it will write that encrypted value into the final file. Once that's done, we can take the file and write it out. So, is there an easier way to do this? Is there an easier, quicker way to do this? We could try and short circuit by doing some tests on if 4 plus 4 is greater than 10. Sorry, got some pings. If the fourth digit, so like 7 plus 6, if that's greater than 10, then we have to do some finagling. Could we could just simply subtract 10 and then subtract that. That works. That's one way to do it. I gotta respond to my kiddo here. Just tapping some buttons. Bloop, bloop. Wait, what is that? That's not what I wanted. Go away. Well, that's me. That's not my kiddo. Where's my kiddo? There's my kiddo. So many taps. So many tabs. Exhilarating content. Watch this guy tap on his phone without looking at his phone. Well, you can't look at my phone. I'm looking at my phone. Yeah, so I'm thinking we could maybe short circuit some of this math. If we did so if we swizz F4 into X and we swizz F, that's not gonna work because we're not guaranteed to find the right one. So what I was gonna do, I'm just gonna show it. So we swizz those two, we add X and T, right, we've got that. Then we're gonna assume it's greater than 10. In this case, we know it's greater than 10 just because it's our test case, so we can skip the test. So once we get to this point here, we've got 13, we subtract 10, we've got 3. So we know that we can subtract 3,000 from a number, right? So we could take, we could mul I X times 1,000, 1,000 X. Store that into X, and then we can simply take, we can copy F, we gotta seek back again. We can copy F into T, and then we can sub I T X into T. And so what that's gonna, let's just put it in X, that's fine. So what that's gonna give us is, now we've got 3,000. Then we can simply add I F to X into X. And that should be our, we're still capped out. We still capped out. Interesting. I know I'm missing something. There's a mathematical trick here that I am failing to miss, so we are going to move on without it. There's always got to be some kind of trick you can do. So our plan of action, we'll have a couple of X's. So our first X is going to be pretty simple. It's going to grab 300. It is going to seek 1 because we don't really care. We're going to link 800. We're going to link 800. What is frequency? 1, 2, 3, 4, 5. Seek 5. Not linking. So 800, 799. Then we're gonna link 800 again. We're gonna copy. That's azimuth. No, that's azimuth. That's what we want. We're gonna copy F to asim. We're going to seek 1. We're going to link -1. We're going to link frequency, right? Elevation is next. Yeah. Then we're going to link 801. We're going to copy F to elev. We're going to link -1. We're going to seek 1, and we're going to copy F to freak. And we're going to wipe the file. So that one's going to grab the file, write these values out. Azimuth 123. Ooh, wait, I just realized. So the instructions didn't really tell us how to move it. As expressed, the dish position is usually expressed in degrees of azimuth and elevation, and the dish itself is controlled with motors. To use motors interfaced as registers that let you read the current position or angle in this case, and a register that controls the motor movement. Write 1 or -1 to move in either direction. Okay, so that's a little more involved. Right, so we will simply jump over to this node where we will spawn some nodes that go move motors. So frequency is pretty straightforward, it looks like, but elevation and motor are not. So we can take the azimuth value that we were going to copy into azimuth, and we can REPL move asm. Yeah, because we are going to have to know what we should read from, right? And we're going to copy. Ooh, we need to copy that out first. Copy the current azimuth into X, move asm, and then we'll copy, copy T1 into T, that's azimuth, and then we'll REPL move, and we'll copy F, and no, we need to seek 1, that's going to be our elevation, and then we're going to copy 0 into T, and we're going to REPL move, and then we're going to seek 1, and we're going to copy F into frequency. Right, where's the data here? That's where we write the data. We just need frequency. Okay, then that should be good to go, so we can wipe and halt that. Then we mark our moves. So our move here is going to be, we got a link somewhere. What do we link into? It's like, it doesn't, we got to know what we're reading from, so we're just going to copy move asm. We don't need to try and get too fancy. We're just gonna straight up duplicate some logic. Yeah, it's gonna suck. But we don't really have a choice. We can't get too fancy with the nodes. Like, we can't store return locations in the codes. We can't have like dynamic jump in and jump out. Like, we can't build actual function calls, basically, that can dynamically return to different positions in the code. So move asm. We're gonna move the azimuth. We need to link 800 from here. We need to, I don't know, sub I. We're at 140 and we want to get to 23. So we're gonna sub I the current azimuth by X and store that into X. And then if that's negative, we're gonna test X less than 0. That is gonna be mark neg asm. And no, we don't want to mark it. We want to T jump to neg asm. Or we're gonna do mark pause. So if the azimuth is positive, If X is positive, then each round we are going to put it in T, right? No, put it in X. Now we can put it into T though. Once we do the test, we could copy X to T, and we're gonna mark P loop. Then we can copy -1 into MOTR. We're gonna sub I. We need to T jump out of here. T jump. Oh. Sub I T -1 into T, and then we're gonna jump P loop. Well, that just really needs to know what to read from, doesn't it? And then we can move. They both use motor to move. So, yeah, once we have that value, then we can jump to move. And then this can be mark move. And this can be just negative and positive. Okay, P loop. We jump back to P loop. And mark negative. We're going to copy X to T. We're not going to do that all in one line because we don't want the mark to be negative copy X to T. Then we're going to mark in loop. And this is going to be T jump halt. Or I should say F jump halt. Copy 1 into motor and add I T1 into T. Jump in loop. And mark halt. It's just going to be at the end there. It's going to halt. So we can, yeah. And then mark, move, LF, link 801. Sub I LF X with X, I guess. Let's see where we're at. We've got boom. This one's working towards 17. We are moving our target. We should end up with an azimuth of 23. And an elevation of something else. I don't remember what the elevation should be. I don't think the frequency changed at all. Okay, we're still going. Our elevation's still going. What is our target elevation? We are going down. What was our target elevation? Elevation of 36. How did we get there? Link 800, right? Oh. That's how we got there, because we're trying to get it to 123. Because we need to copy F into X. There we go. Now it should be, yeah, that should be better. So that's moving down to 6, 36, and we're moving to 123 on azimuth. And the frequency did change to 384. Now that we are correct, right? That should be the target. Yeah, 384 gigahertz. Okay. So the next bit is encoding. Hooray. Okay, so we've got XB is going to link 800, grab 199. Oop. We're going to grab 301. We're going to go ahead and seek immediately past the name because it does not matter. Then we're going to link. We don't want to link 301. We want to grab 301. Then we want to link 800, where we REPL code key, and we'll REPL out. Yes. So let's start with key. So mark key. Key's gonna grab file 199 and mark K loop. That's our key loop. And this one's basically just gonna read. So copy X, M to X, or copy M to T, test, F jump. If it's done, we're gonna halt. So let's go ahead and mark a halt down here. And what's JF? F jump, halt. What do we got? F jump, halt. We then, shoot. I lost my train of thought. The key. Okay, if we're not gonna halt, then we're gonna copy F to M. First we need to test EOF. If we're not at the end of the file, just continue, and I can call it K continue, because then we're gonna seek all the way back to the beginning. And then we'll mark K continue here, where we copy F to M, and then we simply jump back to K loop. It's pretty simple. We just read the key value. Key value, boom. Key value, boom. What if I did read it in parts? Like, we can deconstruct it and we can send it out in parts, component parts, instead of having to constantly split it up into component parts. Interesting. Let us try maybe doing that. So each key, instead of copying, we're going to copy it into X. We're going to swizz. Let's send the main body first. So X321 into M, and then we're going to swizz X against 4 into M. So that's the 1000th place. Remember, the numbers are, so if the number is like 7, 8, 3, 4, the digits are numbered 4, 3, 2, 1. So if we swizz out 3, 2, 1, we basically produce 834, and if we swizz out just 4, we only get the 7 in the 1000th digit. It's a weird tool, but it's fun to, it's like, feels good to use. We don't, yeah, we do halt. Okay, we do halt. Okay, so we've got our halt there. Now we need to mark our output. So this is going to be the node that does a lot of work. Oh, and then we need to read. Mark read loop. Forgot that part. That's kind of the important part. We need to switch to local mode. And we're gonna copy F to M. We can do the same thing. Copy F to X. Then we're going to swizz X 3, 2, 1 into M, and then we're gonna swizz X4 into M, and then we're gonna test EOF, T jump, R done. If we're at the end of the file, then we'll just jump back to R. Mark R done. We're gonna copy -1 to M. I don't think any of the values are gonna be 0. So maybe we can just put 0 to M, I guess. We'll start there, and then we can just halt. We could jump halt, but like jump halt and halt are both one command, so there's no reason. Okay, Now the output node is the one that does all the work, and it's going to be reading from both. So if you've noticed, like this one I left global because we're global by default. We don't switch modes. So the key is always transmitting over global, and the value is always transmitting over local. Now, if we weren't trying to swizz them apart, then it wouldn't really matter. We could both send over the same network layer. But the key is that you can only read global channel when you're in global mode, and you can only read local channel when you're in local mode. So it is a kind of way to create multi-channel communication. This is the only two channels you can create, and you cannot determine who's going to read it. You cannot guarantee in what order they're going to read it. So yeah, this is kind of a way. Like, it doesn't matter if we read the encryption value first or the other value first, because we're adding them together and we're taking what's left. So, you know. Okie dokie. Where were we? We are simply taking, okay, so mark output. So we're just going to mark O loop. That's the standard pattern. We need to make a new file. Now the O loop is going to copy M to X. I guess it should. Who's broadcasting done? The file is broadcasting done. So we need to read from the file first. The file is going to be in local mode. So we do need to switch modes. So we're going to copy M to T. And we're going to F jump finish. Finish. That's what I meant to say. We'll do that. We'll do that later. To do. We'll pretend like that's done. Okay, we're writing a lot of code. We're writing a lot of code here. As you notice, as these challenges go on, like ooh, wow, we only have 25 lines of code left to write. Ooh, this might be some trouble. We can try and reduce some things. I mean, we've got a lot going on here, but I think we can like figure it out. Maybe merge some of this, looping, adding, that kind of stuff. Anyways, where are we? F jump finish. Okay, so if we're not finished, then we know T is the first value, so we can now add I, T. We need to copy him into X. So that's, yeah, and then we're going to switch modes where we copy M to T. Copy to T. This is the code, so we're going to add I, M, T into F. We're going to put that in the F. That's the base digits, and then we're going to add I, M, X into X. Okay, so yeah, boom, boom. We can now test X is greater than 10. If it's not greater than 10, F jump next. So mark next here. Okay. If it is greater than 10, we want to sub I X10 into X, and then mul I. And we mul I. I just realized if it's 9 and we're adding 1,000 to it, is that possible? It is possible. We could have 7,000 and 2,000. That's 9,000, and it could be like 999 and 999. So that's 1,800 something. So that would be 9. That's going to be 10 again. So we actually need one more. We need to seek, and we need to swizz F with 4 into T, add I, XT into X. Okay. Now we've added all 4 of those together. But we need to subtract it now. We've pulled it out. Yeah. It's a little hacky, but we'll make it work. Okay, so we're gonna multiply what's left by 3,000. Why 3,000? I do not know. Multiply X by 1,000. Store that into X. Once that's done, we can seek -1 again. We can swizz out F321 into T, seek -1 again, and we're going to add I, X, T into F. And then we'll jump O loop. We need to switch modes again, don't we? Back to global mode where we go back up here. And boom. Okay, so finish. In order to finish, we need to tell, we need to switch modes, void M. Does it wait? Doesn't it read the key loop? Copy M to T. Oh, okay, so it's waiting. So we actually need to copy 1 to M. And then here, we just simply copy 0 to M. Okay, so I want to keep track of our nodes. Which one's which? This one's reading. What is it doing? What is it doing? I think the read loop is messed up. We copy F to X. Oh yeah, because we do X, okay. And we copy that to M. Where is our output? Boom. Okay, so we know what we want, what our output should be. 5455. So the first value we write out should be 5455. We've got 1433. We copy in some additional numbers. Where did we get that number from? What is going on here? Key loop. Okay, let's see. Let's reduce this node down. There we go. So now we should get, this is our reader. Obviously. This is our key node. And then this is our output node. So the output node is in global. Okay, this mode is switched to local. This one is switched to local. We are reading in the value from here first, where it pulls in 1988, it writes 988. We read 988. This one is 1178. We read in 1. Okay, we write 1. Why are we getting 445? Oh, it's file 400. Okay, over here, boom. 5455, we write 455. It adds So hard to keep track of all of these things in sync with each other and when they're writing each other. Okay, what are we doing? We are reading from reader first. So we read the first value from reader. It writes 988. We read 988. It's not 0. So now we read the next value, which should be 1. 1. We now swap to global mode, where we copy 1 to M, so we tell this one to do its job. It does its tests. It goes here, copy F to X, X321 to M, so it writes 455. This one is adding M to T and storing it in here. So 455 plus 988, where's my calculator? I mean, it's got to be correct, but I just want to double check. So 455 plus 988, 1443, that is correct. We now have, we're writing 5. We read 5 plus 1 is 6. Then we seek back -1. We read that value out. We add it, so we're at 7. That's not greater than 10. We multiply it. We copy out 321. We go back. 7,000 plus 433. And then boom. That's what we want. What is one? Oh, that's 19. I was looking at 199. Oh my gosh. Right here, 7,433. Okay, well, no, okay. So the next value we get should be 3378. Here. 3378. Okay, where's the first one that's gonna wrap? This one's gonna be 1,600 and 6,000, 7,000, and 3050. Okay. Yeah, so 3050 is gonna wrap for sure. So, okay, here we go. And that one should be 1026. So add to that, that's 1. Pull out 26, we add 1,000, that's 1026, yeah. Okay, cool. So everything seems to check out. Just make sure that things terminate correctly. The key node looks like it started over correctly. This node looks like it's working. Ooh, you know what? We never actually write the data. Goodness gracious, the output loop needs to, where does it stop? Finish. So it needs to copy 0M. Can I do it in 5 lines of code? I'm gonna say no, I can't. So we need to link 799. If I make a new exit, that doesn't change anything. Link 799. And then seek -999, and then mark F loop, test EOF, well, we know it's not going to be EOF. We can copy F to data, test EOF, T jump, F jump, F loop. We are at 101 of 100. We need to cut 1 line of code. Where can we cut 1 line of code? One line of code. Maybe we can cut it up here easier. Copy f of x, REPL move asm, because that's linking 800. So if we, yeah, that's just adding an extra one there. Move asm, seek 1, copy fx, move elif, seek 1, copy f frequency, wipe, and halt. If we moved, we could do jump, halt. And then we could put wipe here. How did that not save any code? Because we had halt, we had wipe, and then halt. Okay. Oh boy. We copy 800 into a X, and then we link a X, and we sub. Okay, that's more. Copy F into frequency. Jump halt. Link 800. Sub I ASM. So one thing that I'm thinking is we could simply spawn more nodes, and we could abuse the errors, right? We were told to abuse errors. So if we tried to read from ASM and ASM doesn't exist, like what if we read from there? What's that gonna do? So alt click. Why is that not? Hello, alt. Okay, so let's read from Elif. Fine. All right, so if we're here and we try to read from Elif, hardware register not found. Perfect. That's exactly what we wanted to see. So we can kind of just abuse that a little bit. We copy 800 into T, and then we move. We can change move to link 800 sub I. Link T. Move ASM or move Elif. Wait. Just move, right? We just want to move it. And then move has to determine if it's ASM or Elif. Is that faster if we REPL move? Somewhere it's got to do it twice. I don't think that's faster. What we lose, so if we copy, what I was thinking is we can get rid of the extra links. So how much could we actually get rid of? We've got to do this. And we've got to do jump move. We don't need a mark positive. I don't think that counts as a line. Oh my gosh, it did count as a line. Okay. Well, we don't need positive because we never jumped to it. We do need negative. Do we need halt? We jump halt. Yeah, because we can't just like conditionally halt, so we have to F jump to halt. Or we wipe. Okay, we're in size now. The other one was code complete, so I think we should be good. Now that one is actually finishing. So let's get down here where we finish. I just realized we don't wipe. What are we doing? We're copying 0 to M. What the heck? Why is that suddenly broke? Who's waiting on us? We are local. Keynote is global. Shoot. finish. Yeah. We need to switch modes. We need to switch modes. Which puts us back over 101. Copy 0 to M. Then we link 799. We gotta seek back to the beginning. And what I just realized is we don't wipe the file that we own. Do I have wipe anywhere else? I have a halt here. That now needs to be a jump halt. Oh, reader. Yeah, reader definitely needs to jump halt. So that puts us 102. We gotta save more. This stuff here. Son of a gun. How can we can't get the remainder. We don't have like a modulo. How can we simulate this kind of like wrapping around the values? Like, it's not that easy. Go back to the beginning of your key sequence. Okay, to encrypt a sequence of your data, wrapping back to 0 when the sum reaches 10,000. So if the data value was 7,407, okay, let's try and look at a different wraparound. So their example in here is 7407. So I want to just create a new solution. Let's hop in here. So we're gonna make a file. We're gonna copy 7407 into F. We're gonna copy 3894 into F. So one thought that I had is if we seek back to the beginning of the file, we can't do 10,000, but we can say like sub I 9999 minus F and store that into X, right? That's going to give us 2,500. Then we can add I 1 X to 1 to X. That's gonna, because we had to take 1 off. We can't represent the value 10,000. We can only represent up to 9,999. So that gives us a wraparound of 2,530. So then, how's that gonna help us? What is the result of this? The result of this should be 11301. So let's put that here. 11301. Wait, 11301. So it should be 1301. Should be the output. So if we took that's not working. We took the difference, right? What is 1301? 1301 plus, let's just see here. What is add I 1301 and what is it? Oh, 3804. Yeah, there's no way. There's no way that is, yeah. What if we sub I, what is it? 3804 and 1301. That's a long shot. 2503. And the difference is 2592. Yeah. Oh, how do we do modulo? Okay, I'm gonna not look up the solution itself, but I'm gonna try to look up how to perform modulo without modulo operator. How can I do mod without a mod operator? Well, that's not gonna work. Depending on what you want. So I'm wondering, I'm not wondering, like if just out of curiosity, so copy negative into X, add I, here, add I fxx, add I fxx. Where are we at? We are at 12, 12, and we are at least one off, because we started at 10,000, and then we add up. It should be, what the heck? Even if I added one, what? Why is my math so wrong? Why is my math so wrong? Here we go. It came for programming, and here we are doing a bunch of weird math. I'm probably overthinking this. I got 11 to 11. Why is it 1301? Did I copy the numbers? I probably copied the numbers out wrong. What were the example numbers? 7407 38948. I copied the numbers out wrong. Okay. 3894. Okay. So now we got 1302, and we need 1301, but we started at negative 999. So if we add I, or sub I, x, 1x, can't subtract from there. That gives us 1301. Perfect. We've solved the wrapping, significantly less code. But what if we don't wrap? This one is 3588 and 3280, and we're expecting 6868. I didn't need to make that. Okay. So boom, 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 boom. Okay, if it's not greater, then we could do copy 9999 into T. Oh, we don't even need to do that. We just need to sub I x to x, add I x1x. So we get our negative. Do we even need to copy that? negative. I don't think we need to copy that. Yeah, we do need to add one. Add I x1x. 6868. 6868. Okay, let's test that out on one more. I think we might have found potentially better solution. This one's gonna be 2384 3105, and we want, for comparison, 5489. Boom, 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 boom. I'm wondering, do we even need to add? Yeah, so we only need to add one, right? We only need to add one if it is greater, right? Because we got one of them that should wrap is going to be that 7407, right? 7407. And this one was 3894. I mistyped it again, but I was paying attention this time. And as we saw, we want 1301. So boom, boom. We don't want to add I to it that time. So what we need to do is we want to test x less than 0. If it's not less than 0, we add 1. We add I there. We copy X to F, and we halt. And then we mark add 1. We add I x1x to F, and we halt. Okay, so that writes. Okay, so we want a sub I in this case. If it's greater than, we want a sub I. And if it's less than, we want to, which we can put in, just one more test, 3, because now we got the logic, 3588, 3280. Boom, boom. We got 6868. Perfect, perfect. Okay, we've got our problem down. So this whole mishmash, reading and swizzling, we're not going to do all of that. When we read the value, we're simply going to copy it to M. Yes, boom. When we read the value, we are going to copy it to M. To M. And we don't need these two lines either. We are going to copy -9999 to X. We're going to do our testing. If we're good, we're going to add I xt into X. We're going to swap modes. We're going to add I mx into X. Oh, and we're going to copy 1 to M. Yeah, we got to do that still. We don't need these two. We don't need to do all the writing and the swizzling. Let's just give us some space. We copy -99, we test that, we add it to T, we tell the key to give us a value, we copy that to to X. Now we need to do our test, so T jump, test X is greater than 0. 0 would be 10,000. Exactly. So we'd want to write 0. So if X is greater than 0, we need to subtract 1 from it. So T jump, take F jump, right, or save, I guess. And then here we'll mark save where we copy X to F. And we jump O loop. Swap modes, jump O loop. Okay. Now if we're not saving it, we are subtracting 1 from X and then we're saving it. And that gets rid all of these here, drastically reducing our code size and drastically simplifying our encryption. Shoot, I wasn't checking. Okay, so boom. This one is 0 is going to be our key file. We got a -2566. That's not what we wanted. Oh, shoot. I forgot. Yes. If it is negative, we want to, we have a little bit more code to write. What we actually want to do, test if it's less than 0. No, test if it's greater than 0. If it's greater than 0, T jump sub. Right? And then we'll have mark sub where we subtract into save. If we don't subtract, we are going to add I 9999X into X, jump save. Right, that's what we want. Okay, so we've got this one now and this one. So we're at -999, we got 801. We read a key value. We're at 2566. We add -999 to that, and we save that 7433. Boom, 7433. Okay, the next one should be 3378. Boom. The next one should be 8150. Boom. This one should be the wraparound value. Should be 1026. Boom. Perfect. Perfect. Okay. We're still pushing limits, but not as bad. Not as bad as it could be. Actually, now that we're not swizzling, we can move out a little more. We don't even need to switch modes anymore. Yeah. We don't need to switch modes anymore because we only have 2 nodes that'll be reading and they're talking to each other. The other node's just simply writing. Oh no, one will be reading. One will be reading. And it is the key file. Okay. Okay, that's easy. That's easy. So we swap mode here. Okay, 301. 301 is our out file. Yes, that's the what we want to write. So we want to grab that, and we're going to link all the way to 799 with it. Link 799. We're going to go all the way out there. Once we're done with all that, then we're going to go to local mode. Let's just okay. So test EOF, T-jump are done, copy FM. So that's all gonna stay the same. Key file is gonna be global. So yeah, we switched to local. Yeah, we copied them. Yeah, so we're starting off both. I think the modes are fine. The modes won't change. What will change is that we're not making anymore. So we're just gonna simply loop it up. And then instead of that, we're gonna copy that into data. So once we finish, we'll just do that. Now, oh, what happened? What happened? Oh, nope, we do need a mark out, don't we? Mark out, which needs to link 799. That's what happened. That's what happened. We do need to still do some like work. Okay, we're stuck. We're stuck. What are we stuck doing? We're stuck copying F to M here. You are copying M to T. You are copying M to T. Copying F to M. You're local, and these two are global. Nobody's reading. Why is nobody reading? We're reading global first. Are we? What if we mode? Because we need to read from the key first. I mean, we need to read from the file first. So there we go. Now we write directly here. Skip the file, save some lines of code. This is not something... Well, I guess we... No. Yeah, we could have done this earlier. Without having to rewrite things. What did we not do? Align the satellite dish with the target? What? How is it not aligned? Because we've already started writing data. Where did B go? Wait. Where did B go? Oh yeah, A's over there moving stuff. Oh, wait. Mark Asm? Oh. Okay. It helps if I unbreak it. Yeah, because we wrote to... Okay. Okay, well, we just did all that saving for nothing. Can we bring it all back? Yeah. Yeah. Okay. What are we doing here? Mode. Does mode have to be done there? I don't know where that got borked. So that's writing our encrypted code while the satellite's moving. Yeah, that's just our way of knowing the satellite's been positioned. We could write some extra code, but we're pretty high up, you know, so. What happened here? What the heck? Did you undo the change here? Yes, you did. Gosh darn it. What are we doing now? We'll leave no trace. What got left? What got left? Seriously, what got left? Like boom. That one's gone. That one's... Wait. Are you trying to tell me that I've got to put the azimuth and elevation back to what they were? This is unreal, right? So first I gotta move them into position, transmit the data, and then move it back to what it was. What? Oh, file 199 is being deleted. Oh my gosh, that's so much easier. Okay, we can fix that. Who's picking up 199? The key file's picking up 199. It's jumping to halt. We don't want to... Who needs to wipe? The read loop needs to wipe. Yeah, so we're just gonna call you wipe. And mark wipe, mark halt. And the out loop needs to, I think it ends on its own. Yeah, okay. Oh, that was scaring the crap out of me. Okay, cycles are high, code is high. I'm ready to move on. That was a tough one, not gonna lie. Very challenging premise there. What do you think? I'm not sure I understood it. That's okay. Great art is often mysterious. If you want to know the truth, though, that video was just some garbage data. I just thought it would be fun to broadcast. Alright. Stuff is weird. Life is weird. I had the TV on and this weird, creepy sequence of shapes and sounds came on. It was bizarre. Did you get a recording? I guess I should have. Sounds like an art project. I don't think it was. They don't put art on TV. Okay, we are well past the normal end time because that was tough. So we're going to call it there. Thanks everyone for showing up. I really appreciate your time. Yeah, we'll be back on Thursday, 6 to 8. Look forward to it. And here we go. All right. Cheers, everyone.